Hey everybody, welcome to one-to-one and onto functions, and this is a little bit of an update from a video that I made previously. So today our focus on is determining whether or not a function is either one-to-one or is the function onto or neither. Okay, so let's first start talking about what a one-to-one function is. So a one-to-one function is when each element of the domain pairs to exactly one element in the range. Okay, and then it's said to be one-to-one. So in this case, every different input value maps to a different output value. So when we looked at functions, we would look at the inputs and see if there was any repeats, and that was our red flag. For a one-to-one function, you're going to be looking at the outputs, the range, and seeing if there is more than one arrow going to a number or an element. Okay, if there is, that's a red flag. Then we're going to look at it and say, what's going on? So let's look in the first example here on the left. So we look at the domain. There are three different inputs. They're unique. They're different. And they each go to an output in the range. So if we look, one goes to A, 2 goes to B, and 3 goes to D. Each different input went to its own output. And you can see that C is left off. That's okay. In this case, it doesn't matter. Okay, we know that each different input, each element of the domain paired with one output, and they each went to a different output. Okay, so the idea here is if I'm looking and I look at my range values, do I see a double arrow going to any of those elements? The answer is no. In this case, it's a one-to-one function. So let's look when something is not a one-to-one function. So when you look at the second example here, if we're looking at the range, so let's look at our elements there. And we see that 5 has two numbers going to it, two elements going to it. It's -1 and 1. So let's look at it. Look, each element of our domain maps to something in the range, so it is a function, but each of these different elements needs to go to its own number in the range, and it's not the case. So that function is not one-to-one. Okay, so let's turn now our attention to what an onto function is. Onto functions, okay, each element of the range corresponds to one element of the domain. So meaning each range value is paired with a domain value. It has a friend. Each element in our range has a friend that goes to it. That's it. It can be doubled up. It just has to, each value in our range, each element in our range has to have a buddy. Okay, so let's look at an example. So if you look at the graph on the left, that's an onto function. If we look at our range values, you see how each of them have an arrow going to it? Each of them is paired with something from the domain. That's an onto function. And you notice our value for C, our element C, has 2. Okay, so here's a great example where the function is onto, but not one-to-one. Okay, notice that in our range, we're looking at, does it have a buddy? So let's look at our second example, and if you look right here, if you look here in the range, guess what value doesn't have a buddy? 4 doesn't have a buddy. This function is not onto because it doesn't have a buddy from the domain. It's got to be paired with someone from the domain. So if you think about this, functions, determining if a relation is a function, we've been looking at the inputs, the domain. When you talk about one-to-one and onto functions, you're really kind of looking at the range for the trick. Okay, for the onto function, hey, does every range have a buddy? If it does, you have an onto function. If every element in the range has only one thing going to it, one thing from the domain, and they're different, then it's a one-to-one function. If you're both one-to-one and onto, it's called a bijection. You're bijective, meaning you're both one-to-one, injection, and onto, a surjection. Okay, so if a function is both one-to-one and onto, we're said to be a bijection. So check it out. Here's an example. We're looking at our buddies from the range again. Look at every element has a buddy. It's got an arrow going to it. And each range value only has one arrow going to it. So that's great. If there was a 2 like this, if I drew that in, nope, it's not 1-to-1 anymore. It would just be onto. Okay? So let's look at an example. Determine if the following relation is 1-to-1, onto, or both. Well, number one, we have all different values for our function, our relation. So this is a function. If it's not a function, we would just stop the process, because onto and 1-to-1 functions, if we have a relation that's not a function, this is out. All right, so let's try a mapping diagram. Okay, so let's put our inputs in here. So I'm going to go ahead and draw my inputs. -6, -5, -3, -1, and 6. Okay, then I'll draw my outputs. Okay, not great drawings. Outputs: 1, -9, -7, 7, and -9. Okay, let's match those up. -6 went to 1, -5 goes to -9, 3 goes to -7, -1 goes to 7, and 6 went to -9. And notice how we have 2 -9s. I actually didn't need to do that one. And I'll change colors here. And look what happens. Now each one of these has a buddy, right? All of these have a buddy in our range. So this function is onto. Okay, however, it's not 1-to-1. And the suspects are right here. The -9, look at, there's a repeated y value. That's a problem. All right, let's look at this mapping diagram. Is it 1-to-1, onto, or both? Well, each different input has an output. Okay, so here's our suspect. That one doesn't have a buddy, so this is not onto. Okay, could still be 1-to-1. Okay, does each input go to one output? Let's see. Different 3. Okay, oops, there's a double up right there on 6. -1 and 1 both go to 6. That's a problem for 1-to-1. So this is not 1-to-1. So it's neither. This function is neither 1-to-1 or onto. Okay, so there you have it for 1-to-1 functions and onto. If you have any questions or comments, please feel free to type them in the comment box below, and we'll see you next time.